Hi everyone, this is U Science Lab and we are welcoming you to another exciting video on physics. In today's video, we are going to be looking at a problem on moment of forces. So I have a question with me here. I will just go through the question and find the solutions to the problem and the questions that follow those. So let me read. A plank AB 3.0 meters long, weighing 20 kilograms and with its center of gravity 2.0 meters from the end A, carries a load of mass 10 kilograms at the end A. It rests on two supports at C and D as shown below. So this is the diagram. So you can see this, the write-up describes what we have on this diagram. The only thing that is missing here is the mass of the beam or the weight of the beam. We are going to include that. So we are told that this is the beam. It is 3 meters long. We have end A and end B, and this is end A is 50 cm from the pivot here, pivot C, and end B is also 50 cm from pivot D. Then from the write-up, we're told that a mass of 10 kilograms hangs freely from point A. So what I'm going to do is to write the first diagram for this, including the mass and the distance from any point we want to take moment from. Now, these are the reactions at C. Reaction at C is given as R1, and reaction at T is given as R2. Let me quickly run that through the remaining part of the question. So we have to compute the values of the reactions or the reaction forces R1 and R2 at C and at T2. 2. How far from D and on which side a mass of 24 kilograms be placed on the plank so as to make the reactions equal. So again, what are their values? Then the last part is identify, okay, without this 24 kilogram, what vertical force applied at B will lift the plank clearly off D. What is the reaction then at C? Let us go back to the diagram and see. So this is the diagram. So we have run through that. When we are looking at the solution, we go back and look at whatever they ask us to look for. So the first thing I'm going to do, I'm going to draw this uniform beam, this beam, and I'm going to include the force diagrams. Now this will represent the beam. So I'm going to put the diagrams, I'm going to convert this, I'm going to change this to force, then I'm going to indicate where the weight will add to. Remember that they said that the weight of the object is, or the center of gravity of this plank is 2.0 meters from point A. So I'm going to include all of that, all of this on this diagram. Okay, this is the diagram for this. Now I have converted all masses to weight. I multiply the mass 10 kilogram by 10, the approximated value of acceleration due to gravity, to become 100 Newton. And the weight, you can see that I've placed the weight of the object 200 Newton. So it was the mass is 20 grams. So I multiplied it by 10 to get 200 Newton. Then the reaction remains the same. Now all the distances, this was 50 cm. I have converted it to meters by dividing by 100, so that's 0.5 meters, and also with this. Now the distance between this as given in the diagram remains, which is 2.0 meters. Now what I'm going to do is this is assumed to be in horizontal equilibrium. Since it is in horizontal equilibrium, the sum of the upward forces must be equal to the sum of the downward forces. So the upward forces are R1 and R2, and the downward forces are 100 and 200 Newton. So I'm going to do this. R1 plus R2 must be equal to 100 plus 200 is 300 Newton. So that's the first thing I have to do. So that's the sum of those vectors. Now I have to take moment about either this point C, or point D. So I'll take moment about point C or point D. Now the essence of doing this, because we have two unknown forces at C and at D. So when we take moment about either of these, one of the moment due to the force R1 or R2 will be cancelled. So for simplicity, I'm going to take moment about C. So taking moment about C, so this is what we're going to have. I'm going to mark out the clockwise and anti-clockwise moment. So we are taking moment about this point here, this point. So the moment due to R1 is already 0. So let's look at how this beam will rotate due to forces 100, 200, and R2. Now if I take moment about this is pivoted. You will notice that this force is going to rotate this beam in this direction. So definitely this is going to be what? An anti-clockwise moment. So I'll write this ACW, meaning anti-clockwise moment. Then if I pivot this again, this beam is going to rotate in this direction. Look at it, this force is going to rotate this beam about this pivot in this direction. So this is going to give me clockwise direction. And this also, with this pivoted, this force R2 is going to move this beam, is going to allow it to rotate in this direction. So this is going to be what? Anti-clockwise moment. Now how do we know clockwise and anti-clockwise moment? We know clockwise and anti-clockwise moment due to the rotation of this beam in the direction in which the actual clock rotates. If you rotate in the opposite direction, that becomes what? Anti-clockwise moment. So having known the clockwise and anti-clockwise, let's take the distances, their moment now. So by principle of moment, clockwise moment, I'll use this abbreviation, is equal to anti-clockwise moment. That sum of clockwise moment must be equal to sum of the anti-clockwise, because the beam is what? In horizontal position. So what I'm going to do is this. So let's take that distance, the moment. So the clockwise moment is 200 Newton force, that's the weight of the object, times the, now I have to determine the distance between this and this. Remember that the distance of this, of the force 200 Newton force, which is the weight of this beam, is 2.0 meters from end A. Okay, this is my end A and this is my end B. So what I'm going to do is this. Since from here to here is simply 2 meters, and from here to here is 0.5, then the distance between this and this is going to be 2 minus 0.5, and that's going to give us 1.5. So this is necessary. You need to get the distance from the point you are taking moment from the perpendicular distance. So having taken that now, I know that my clockwise moment 200 times the distance between this and this, which is 1.5, must be equal to the sum of their clockwise. So this is anti-clockwise 100 times the distance between this and this pivot is 0.5 plus, so we have the distance between R2, which is the third force. The distance between R2 and this is simply 2, so this will give me plus 2R2. So we have that. So working this out, this is going to give me 300 equals 50 plus 2R2. From here you can simply see that 2R2 is going to be equal to 300 minus 50, that's 250, and R2 is going to be equal to 250 divided by 2, and that will give me, so that's 125 Newton. Now again, you know, we have gotten the reaction R2, so we go back to look for R1. So we substitute this. R1 plus R2 is 300 Newton. So definitely R1 is going to be equal to 300 minus R2. That will give us this. So you see this. So R1 is 300 minus R2, and I substitute the value of R2 for this. So R1 is equal to 300 minus 125, and that gives us 175. So that answers part A of this question. The part A of this question is that we should compute the values of the reaction forces R1 and R2 at C and D. We've just done that. So let's move to the other part. We are now told that how far from D on which how far from D and on which side, okay, how far from D and on which must a mass of 24 kg be placed on the plank, on which side from D, that's what it means. How far from D and on which side, so that side, there should be a side. So on which side must a mass of 24 kg be placed on the plank so as to make the reactions equal? What are their values? So what I'm going to do is this. I'm going to recreate this diagram here. Then I'll put X value. I put a value from D. This is D. I can put it on this side or this side, depending on when it is. If it is on this side, we'll get a positive value if I place it here. If I place it here and it's on this side, I'll get a positive value. Otherwise, if I get the negative value, it means that it is actually in the opposite direction. So what I'm going to do is this. I'll just place my force 24 gram. I'll place it just beside this. So I'm going to draw another diagram to replicate this so that this will not be clumsy. So I'll just replicate that and place S in this position here. Now this is what I have done. The same diagram. This weight is 100 Newton, which is the previous weight. The distance between this and this is still 0.5. The distance between this and this is still 1.5, which is the center. Okay, this is 200 Newton, which is the weight of the plank. And the distance between this and this is still 2.0 meters. The distance between this is still 0.5. So what I just did is to place the 24 kilogram mass. So the weight is now 240 Newton between this and this. So on placing this between this and this, I gave the distance to be what? S. Again, I'm going to, now you can see that here I wrote arrow and arrow, not R1 and R2, because they said they are not equal. So since they are equal, I denoted them by what? Just arrow. So the next thing we have to do is to do this. Take moment again. So I'm going to take moment about point C again. So I will not be writing much on that. So I'll take moment about C. So taking moment about C, the upward forces must be equal to what? The downward. So it means that 2 arrow, okay, let me check. 2 arrow must be equal to 100 plus 200, that's 300, plus 240, that's 540. So when I work this out, R equals to 540 divided by 2, which is 270. Now remember they asked from that question, what are their values? What are the values of the reactants at these 2 points here? So since they are equal, their values are simply what? 270 what? Newton. So that is the value we have for that. Now the next thing you have to do is to calculate, to get the distance now. So I'm going to take this again. I'm taking moment about C. So I'm going to take C, and that's why I have already taken the distance between this point and this point to be what? X. So if I pivot this again, if this is pivoted, the distance, so this is going to rotate in the anti-clockwise direction. Okay, let me change my pen. Anti-clockwise. So I'm going to pause this and take all the moments. So I have taken the direction of the moment. So this is anti-clockwise in this direction. This is in this direction about this pivot. That is clockwise, and this is clockwise in this direction, and this will go anti-clockwise. Remember that this is already 0 because I'm taking moment about this pivot here. See, so the moment of this due to arrow is equal to what? 0. Now let us apply the principle of moment again. By the principle of moment, clockwise moment must be equal to what? Anti-clockwise moment. So now let's get the moment. So I've already done this out, so I can do this by taking the moment now. So our clockwise moment, our anti-clockwise moment is this, that is 200 times 1.5. So I'm going to have 200 times 1.5 plus, so we have this this is also clockwise, that's 240 times s. So I have 240 times x must be equal to the anti-clockwise moment. So the anti-clockwise moment are this 100 times 0.5. So I have 100 times 0.5 plus, now I'm going to have the distance between this and this remains 2. So 2 times r, that's 2r. So that is what we have there. So we have this. Now the next thing I have to do is just to multiply out. So I have 200 times 1.5 is 300 plus 240x